Good morning, afternoon, and evening, everyone. My name is Greg Chang, and today I'll be presenting on the association between alcoholic substance abuse on key HIV outcomes, results from 6 population-based HIV impact assessments conducted in Southern Africa. For the background on the analysis, in a 2007 review of 33 empirical studies on HIV and alcohol use, they found that alcohol consumption was associated with increased HIV infection risk via engaging in risky sexual activity such as condomless sex and having multiple sexual partners. In a review of 53 studies, the authors found that 77% of the studies showed a negative association between alcohol consumption on one or more stages of the HIV treatment cascade. However, alcohol studies in general have important limitations, including inconsistent metrics for hazardous drinking categorization and the use of convenient samples such as HIV clinics, bars, and nightclubs. The primary objective of this analysis is to estimate the impact of hazardous drinking on key HIV indicators. For the methods, we conducted a pooled analysis of population-based HIV impact assessments, or PHIAs. PHIAs are nationally representative household-based surveys conducted to measure each country's progress towards HIV epidemic control through the accomplishment of the 90-90-90 targets. These targets, which we will look at in the analysis, are getting 90% of all people living with HIV to know their HIV status, 90% of all those that know their status to be on treatment, which we will call the conditional treatment, and 90% of those that are on treatment to be virally suppressed, which we will call the conditional viral load suppression. In terms of the inclusion criteria, we included 6 out of the 13 completed PHIAs that included the 3 composite questions of the WHO's Alcohol Use Disorder Identification Tool, CONCISE, or Audit C. These PHIAs include Eswatini, Malawi, Namibia, Tanzania, Zambia, and Zimbabwe. Finally, the analysis was limited to HIV-positive adults aged 18 to 59 years old who consented to survey interview and blood draw and had a PHIA HIV status. This slide outlines the Audit C, which again was developed by the World Health Organization and is used to identify patients who are hazardous drinkers. The tool consists of 3 questions that you'll see on the right, where each answer is given a point value of 0 to 4. Men with scores greater than or equal to 4 and women with scores greater than or equal to 3 are considered hazardous drinkers. However, when all points come from question 1 alone, the individual is not considered a hazardous drinker. For example, an individual that answered E to the first question and A for the next 2 questions is not considered a hazardous drinker. For the analysis, we look at the prevalence of key HIV indicators comparing hazardous drinkers versus non-hazardous drinkers. These include awareness of HIV positivity status among all HIV positive individuals, treatment among those aware of their HIV status, which we would call the conditional, viral load suppression, defined as having less than 1,000 HIV RNA copies per milliliter of blood among those on treatment, which we also call conditional. In this analysis, we measured the association between hazardous drinking and these HIV indicators using a logistic regression model where we calculated adjusted prevalence ratios. For this model, we adjusted for urban versus rural residents, age, and wealth quintile. Across the 6 PHIA surveys included in this analysis, there was a total of 14,296 HIV-positive individuals. Among those that were HIV-positive, 6.6% of women and 21.7% of men were considered hazardous drinkers. 10.1% of women and 27.1% of men live in urban areas. 9.5% of women and 26.6% of men were in the highest wealth quintile. And the average age of women was 36, while slightly higher among men at 39 years old. This slide shows the HIV care cascade among hazardous drinkers and non-hazardous drinkers by gender. On the y-axis is the total percentage of people living with HIV, and on the x-axis we have alcohol drinking status. The first set of results are the proportion of HIV-positive women that are aware of their HIV status, where there is no difference by drinking status. The middle bars are the proportion of individuals on treatment where hazardous drinking women were less likely to be on treatment. I also wanted to point out that the percentage you see inside of the bars are conditional percentages. For example, the percentage you see here is the proportion of women that are aware of their status and on treatment. The light bars are the proportion of individuals that are virally suppressed where there is no difference by drinking status. Switching over to men, male hazardous drinkers were less likely to be aware of their HIV status, where only 52.5% of hazardous drinkers know their HIV positive status, compared to 68.7% of non-hazardous drinkers. However, once men are aware of their status, there is no difference in initiating HIV treatment and subsequently virally suppressed. This table shows the results of our adjusted prevalence ratio model, where we adjusted for place of residence, age, and wealth quintile. Among females, we see that there is no difference in awareness, conditional treatment, or conditional viral load suppression status by drinking status. For men, we found that hazardous drinkers were 1.54 times more likely to be unaware of their HIV status compared to non-hazardous drinkers. As I mentioned on the previous slide, once men are aware of their HIV status, we found that there is no difference in initiating treatment and then becoming virally suppressed. Results from this analysis show that hazardous drinkers perform worse along the HIV care continuum compared to non-hazardous drinkers. Because of this, there is an increased need, especially for men, for more targeted screening interventions. One such intervention is an electronic screening and brief intervention tool, which includes a structured set of questions used to screen and identify individuals that are at risk for alcohol use disorder. Screening is then followed up by a brief intervention and, if needed, a referral to treatment. For the conclusions, among HIV-positive men, 21.7% were hazardous drinkers. HIV-positive hazardous drinking men were more likely to be unaware of their HIV positivity status compared to non-hazardous drinkers. However, once aware, there is no difference in treatment and viral load suppression. For HIV-positive women, there is no difference between awareness of HIV status, treatment, or viral load suppression by drinking status. Thank you all for taking the time to listen to my presentation, and I will now be taking questions.